It's Algebra 2, test number 3 for the springtime. Part 2, we're picking up on number 24. 3p to the fourth times 4p to the fourth plus 7p to the third plus 4p plus 1. You need to distribute the 3 to all of the terms. Times 4 is 12. Times 7 is going to be a positive 21. Times 4 is going to be a positive 12. And times 1 is going to be a positive 3. You also have to do the same with the variables. Remember, when you multiply the same base, like p times p, you add the exponent. So it'll be p to the fourth plus 4 will be 12p to the eighth for that one. Same thing with this one, p to the fourth times p to the third. You add those, p to the seventh. P to the fourth times p is going to be p to the fifth. Notice it skips 8, 7. It skips the sixth one. Okay, p to the fifth, and then p to the fourth times 1 right there will be 3p to the fourth. So that whole thing right there, you can't put any of those together because they're not like terms. For number 25, I'm going to go down here with it. You're going to do the same thing. Distribute 2x times x to the sixth, or 8x to the sixth. 2 times 8 is 16. X squared times x to the sixth. You add those exponents again. 2 plus 6 is 8. And 2x squared times 2y to the third. 2 times 2 is going to be plus 4. These are not same bases, x squared and y to the third. So you simply write x squared y to the third. 26, we're doing the same thing. We're distributing 7a to the fourth times 7a squared. 7 times 7 is 49. A fourth times a squared, you add them again. A to the 2 plus 4, or 4 plus 2 is 6. 7 times negative 8 is negative 56. Again, not like bases a and b, so it's simply a to the fourth, b to the fifth. Distribute 5a squared times 3a to the fourth. 5 times 3 is 15. A squared plus 4 is going to be a to the sixth. 5a squared times 3b is going to be plus 15. 5 plus 3 is 15. But again, you have a and b, so you don't add them together. A squared and simply b, which is to the first power. Same thing with this one. 8p squared, 8p times negative 3p squared. 8 times negative 3 is negative 24. P times p squared, you add 1. You add p to the first plus p squared. 1 plus 2 is 3. Same thing with this one. 8p times 6p is going to be plus 48. 8 times 6. P to the first times p to the first, you add 1 plus 1 to get p squared. And 8p times negative 2 is negative 16p. 29, solving this equation. In order to solve an equation that is a quadratic like this with x squared, you need to make it equal to 0. Right now it says equal to 25. So in order to make it equal to 0, we need to subtract since it's a positive 25. When you do it there, you do it here. 25 minus 25 is going to make it equal to 0. Now what we have is x squared plus 10x plus 25 minus 25 is 0. There's no reason to even do that. So what we want to do from there is we want to factor out an x, because x squared and 10x have an x in common. X times x is x squared, and x times positive 10 is 10x. So x and x plus 10 is 0. So now we have these two separate equations. X is equal to 0, and x plus 10 is equal to 0. So right here, we already have one of the answers, 0. The other one is when we undo plus 10 by subtracting it on both sides. 0 minus 10, x's value is negative 10. So the two answers that go with this one are both 0 and negative 10. For number 30, you have variables on both sides, but before you try to undo anything, you have to simplify the right side. Negative 6 is multiplying by y and negative 3. So distribute it. Negative 6y and negative 6 times negative 3 is positive, since a negative times a negative is a positive, 18. So negative 6y plus 18. You still have 8y minus 4 on the left. Bring your smaller y value over to your larger one. Undo minus or negative 6y by adding 6y. If you do it there, do it here. 8y plus 6y is 14y. You still have minus 4, and you still have equals 18. Bring your minus 4 over to this side by adding 4 to both sides. So 18 plus 4 is going to be 22. So you have 14y is equal to 22. And when you divide by 14 on both sides to get y by itself, y is equal to. Now we can simplify this because the number 2 goes into both of these. It goes into 22 11 times, and it goes into 14 7 times. So y is equal to 11 over 7. Distribute 6 to both of these. 6 times y is 6y. 6 times 3 is positive 18, and that's equal to 90. Now what you want to do is undo to get y by itself. Undo plus 18 by subtracting it on both sides. So we have 6y is equal to 72. And then undo times 6 by dividing by 6 on both sides. 6 goes into 7 once, and it goes into 12 twice. So y is 12. 32 says factor this expression. Remember, we have a trinomial. We're making it two binomials, x times x. In order to factor 44, your factors of c, 1 and 44, 2 and 22. 3 doesn't go into it. 4 goes into it 11 times. 4 times 11. 5 doesn't go into it because it doesn't end in 5 or 0. 6 doesn't go into it because 6 times 7 is 42. 7 doesn't go into it because, again, 7 times 6 is 42. And 8 doesn't go into it, neither does 9 or 10. So these are the only three pairs of factors we have. You need to determine which pair of factors is going to get you to b's value, 7. So which one of those, when we put them together, if we put 1 and 44 together, we're going to get 45 or 43. That's not 7. When we put 2 and 22 together, we're going to get 24 or 20. That's not 7. 4 and 11, we're either going to get 7 or we're going to get 15. So 7, that's the only pair that will give us 7. So we need to do 4, and we need to do 11 here. This sign right here in front of C is negative. It tells us the same sign or different signs. Negative means that they're different. Since they're different, this sign tells us whichever number is bigger is going to be plus. So 11 is plus. They're different. 4 is minus. X minus 4 times x plus 11. Rewrite this number in the form a plus bi. Remember, this is asking you for the square root of a negative value. There is no number when you multiply it by itself will give you a negative value. So we created an imaginary number to remove the negative value. So I, when it multiplies by the square root of 25 will remove the negative. So I times the square root of 25 plus 7. We know what the square root of 25 is. What number times itself? It's 5. But it's both positive and negative. So it's positive and negative 5 times I, just reordered those, plus 7. It asks us to put it in the order a plus bi. So put this a form first. 7 plus or minus 5 times I, a plus bi. Solve this quadratic by completing the square. Remember, to complete the square, you need a perfect trinomial, which means you need a perfect value for your C. Right here we have 21. There's no perfect square in C. So we need to move that 21 over by subtracting 21. When we do it there, we'll do it here. Now what we have is something that says x squared plus 8x plus C is equal to negative 21. We need a new C value. So we're going to create a new C value by taking whatever B's value, in this case 8, dividing it by 2, and squaring it. 8 divided by 2 is 4, and 4 squared is positive 16. That is our new C value. But remember, when you add 16 to one side, you must add 16 to the other side as well. So negative 21 plus 16 is negative 5. So what we have now is a perfect trinomial. That's what this is. Because we could take the square root of the first term, we get x. We could take the square root of the third term, the square root of 16 is 4, and we know this sign in front of b is the one that goes between those two. So x plus 4, when you square it, is equal to negative 5. Now we can solve this to find out what x is. In order to undo x plus 4 squared, we know we take the square root of that side. When you do it to the left side, you must do the same to the right side. This will cancel out this and simply leave us with x plus 4 is equal to, now we have the square root of negative 5. Just like on the last problem, when we had a square root of a negative value, you can't multiply that by itself to get a negative value. So we need to remove the negative by multiplying it by I. So I times the square root of 5. We also need, in order to get x by itself, we need to undo this x plus 4. We want it to say x is equal to, not x plus 4 is equal to. In order to do that, we need to subtract 4. So when you subtract it from the left, subtract it from the right, or we'll do it right here. Subtract 4. Okay. Again, if you wanted to say a plus bi, since it is the square root of something, we'll make it simply say x is equal to -4, there's the a value, plus or minus the square root of 5 times I. There's no perfect radical or no perfect factor in 5. And it's both plus and minus. Since the root of it is 2, it is an even amount. Rewrite the equation in vertex form. You're going to do the same thing for this one, except we need a very similar to completing the square. We bring 7 over by subtracting it. Do it here. So now we have something that says y minus 7 equals x squared plus 8x plus c. Again, you need a new c value. So you take 8 divided by 2, it's 4, and you square it, so it's the same 16 we had a second ago. When you do it to one side, remember you must do it to the other side. So y minus 7 plus 16 is a positive 9. So y plus 9 equals, we have a perfect trinomial again. We can take the square root of this and get x, the square root of this and get 4. This is the sign that goes between them, plus 4, and that whole thing is squared. We are almost to vertex form. Vertex form is when we have y all by itself. So we need to get rid of plus 9. When we do it there, we need to do it here. You can't take it away from 4 because it's inside of the parentheses. So we have something simply that says y is equal to x plus 4 squared minus 9. This is vertex form. Remember, now you can see what the vertex is. It is the opposite of what it says with x. It says x plus 4, so your x value would be -4, and it's exactly what it says outside of the parentheses for y, -9. -4, -9, when you graph this, would be where the graph is the bottom of the graph, the minimum of it. Solve this one by finding square roots. Again, we're just kind of going backwards with everything we're doing. Undo 2 times x squared. Remember, you work order of operations plus says, please excuse my dear Aunt Sally. When you undo, you go backwards. We have multiplication before we do this exponents / radical step. So in order to undo this, we divide by 2 on both sides. X squared is equal to 6 divided by 2 is 3. In order to get x by itself, we want to undo squaring something. So you take the square root of it. If you do it to the left, do it to the right. X is equal to both positive and negative the square root of 3. 37 says rationalize this. Multiply, you cannot have a radical at the bottom. Anytime you do, you need to multiply whatever that is over itself times the whatever you're dealing with. 4 times the square root of 3 will look simply like that. 4 times the square root of 3. The square root of 3 times the square root of 3 gives you the square root of 9. Or you can see, since you're doing the same radical by itself, you pull a radicand out. 4 times the square root of 3 over 3 is the simplified version of it in radical form. And number 38 tells you to multiply these two binomials by each other. -3 minus the square root of 3 times 8 plus the square root of 3. FOIL, FOIL. The -3 times 8 is -24. O is your outer terms. Remember, think of it as a dartboard, inner and outer. Your O terms are your outer terms, -3 times the square root of 3. -3 square root of 3, just like that, just like I said it. I is the inner terms. Again, think of it as a dartboard, the inside. This one times this one. Negative square root of 3 times 8 is -8 square root of 3. And then L is your last terms. L stands for last. Negative square root of 3 times positive square root of 3. Negative times positive is going to be a negative. And again, square root of 3 times the square root of 3 gives you square root of 9, just like it did on this problem right here, the square root of 9, which comes right back to being -3. So now at this point, just combine the like terms. Your like terms here are your constants. This one, -24 and -3. When you put those two together, you get -27. And your radical terms, -3 square root of 3 and -8 square root of 3. Since they have the same radical, you can say -3 minus 8, which is -11 square root of 3. And this is the simplified version of that when you FOIL those two radical binomials by each other.